Hey guys, welcome to this new video series on Databricks Declarative Pipelines. Over the time, we have seen that declarative pipelines are gaining attraction. Even though they started or they've been introduced around 1.5 years back, still we see a very slow adoption due to some challenges. We just wanted to understand in this video series of 52 videos how Databricks Declarative Pipeline works and how their evolution driven by AI and ready for AI world. Let us try and understand first of all what is a traditional ETL pipeline works. Let us check one code sample so that we get the direct example of it. So how the traditional, what I call the traditional ETL pipeline is, so this is the traditional ETL pipeline. In this you can see that there are certain libraries that we import, and then we create a Spark session, and then we use that Spark session to create the or to extract the data, read the data, extract the data, and then we use different transformations like data quality checks, or for that matter, we do some transformations like casting, we do some deduplication, and after all these things are done, we create some new columns, and finally write it back to the table or maybe some location. We have also added some exception handling, and then finally stop the job. So this is the traditional ETL pipeline code, which is then embedded in the in like different frameworks like Airflow. In AWS, it is being put in AWS EMR serverless, or in Databricks, it is put in some notebooks or Python file, and then they are run over and over again. So this is how we build the traditional ETL pipeline. The challenges with traditional ETL pipeline is there are a lot of complex dependency management you have to do. So if your pipeline needs a certain things to work, you just need to add all those dependencies and make sure that they are being versioned over the time. You have to maintain them. All those things you have to plan and do. If there is a if there are a lot of ecosystem which are running around, so let's say Airflow is triggering your job, then you need to be they need to make sure that the error is propagating and all. So all those things like error propagation, failure propagation, or versioning of libraries that we use, all those things you have to manage yourself. This um, takes about 30 to 40% of engineering effort when you build the job. Then comes the data quality, right? So nowadays data quality is very important since AI is being used um, for on top of data. So data quality plays a very critical role. So if you are building the traditional pipeline, then definitely you need to build your own data quality framework, ensure that the behavior is proper and all. Compared to, let's say, declarative pipeline, you have a complete new framework there. So data quality definitely a very big trouble that you have to manage when you are building the traditional data pipeline. Then comes the infrastructure management overhead. You have to manage the complete infrastructure. What kind of cluster you need, what size of cluster you need, what type of scaling for that cluster you need, and then what is the version of Spark that is being installed there, right? And then installing other dependencies. All these things definitely gives a overhead time as well as the complete manual thing, something that you have to plan. Even that takes a huge amount of effort, and eventually there are many cases where it leads to under provisioning, over provisioning of resources, and may lead to your cost runs. The next set of things that you have is schema evolution. Definitely schema evolve over time. Some column get added, something get removed, column gets renamed. In that case, traditional pipeline jobs completely fail. Even in traditional pipeline, you can add like what behavior of your pipeline should be when the column is added, renamed, or something. But then that is uh, you have to write down that code and continuously maintain it. So there is no built-in kind of a schema evolution behavior present because of all these things. So there is another additional challenge is observability, right? So you need to log what has happened within the job run, what are the metrics of job, what are the metrics of data quality. You need to explicitly write down some framework and write continuously to some or the other table, right? So these are the challenges that you see in the traditional declarative data pipelines. These are the challenges that you see in the traditional pipelines. Compared to that, what declarative pipeline bring in is a complete automated DAG construction, a built-in data quality framework, automatic infrastructure management, schema evolution, automatically handled, built-in observability, then different modes, recoveries, and in terms of cost also, it is pay as you go. So all these things, which are the challenges in traditional pipelines, is being managed in a better way in a declarative pipeline. What benefit this brings in is the advantage that you bring in. The advantage that you bring in because of this is there is a 70% reduction in code. There is a 5 times faster development, 90% lesser boilerplate code that you need to put, and debugging is instant. One of the best thing that you have received as a part of Databricks Declarative Pipeline push is the dedicated IDE for building the declarative pipeline. So if you see, there is a dedicated IDE present, and that dedicated IDE is something in which you can build the ETL framework. So this is the first of its kind, and on left hand side you can just put all your sequels that are needed, and this is the IDE that is there, and within the IDE you can very easily set up the things like where the code is present, what is the compute that you would use, where you want to store your logs and everything. Notification, all the things are present here. And it also has one of the nicest feature called dry run, which tells you that if there is any code issue without even running on the data. So typical traditional ETL developers would understand that this is the best in class thing that can happen on the ETL build-up, bringing all these things out of the box with some turn declarative syntaxes is an advantage that saves the developer's time and improves the productivity. It also improves the operational excellence and cost efficiency as well. So all in all, declarative pipelines are better, or rather a much advanced version of what is there as a part of traditional ETL development. So therefore, we'll try and understand the declarative pipeline. And one last thing before I close this video is Genie code is there that can help you build these pipelines. In this video, we are going to understand how Genie code can help me build all these pipelines. It's completely integrated, and you can very easily build pipelines with just few prompts. So with this, I'll end this first video, and in next video, we are going to try and understand how the traditional how the declarative pipelines look compared to um, traditional pipelines, and also we will try to take one sample and try to build one pipeline with some prompts. Okay, so let's begin this journey, guys. Thank you for listening. Thanks again.